Hello friends, welcome to session 11 on projection of plane surfaces. We'll continue with front view starting problems even here. See here, we'll continue with front view starting problems. How you identify a front view starting problem is hexagonal lamina of size 30 mm has a corner on VP their side. Okay, if they say corner on HP, we would have started from corner position top view. But when they say corner on VP, you must start from the front view corner position. This resting on HP, I'll come to that later on. Don't worry about that. And rotate it about this corner till the diagonal container the corner is inclined at 30 degrees to VP. And the front view of the diagonal container in the corner is inclined at 45 degrees to HP. Draw projections and all that. This is a problem. Okay. Now the one clue what you got by reading the problem is it's a hexagonal lamina, has a corner in VP, not on HP, has a corner resting on VP, and rotated about this corner till the diagonal contained in this corner is inclined at 30 degrees to VP or surface inclined to VP. There are two conditions which will tell you that you have to start from the front view. That means the surface are diagonal inclined at 30 degrees to VP and a corner on VP. Both the conditions will tell you that you have to start from the front. Okay, as usual, start A dash, B dash, C dash, D dash, E dash, F dash. In that way, compulsorily start from the front view. And when you're looking from the top, now A can be seen, F can be seen, B cannot be seen. When you're looking from here, F bracket B. When you're looking from here, E can be seen, C cannot be seen, E bracket C, and D. This is the top view, and this is the front view. You have started from front view. That is why we call it as, we bring it under front view starting problems. Okay. Now, what you should know is, since this is a corner position, whether you pull this down or pull this down, it will be corner only on VP. Okay. Here we want corner in VP. You see here. Now, this, I have pulled it in such a way, A is lying on VP and the surface are diagonal inclined at 30 degrees to VP. Please understand here. This is A dash G dash. Yes, imagine this is a diagonal. This is a diagonal, no? This is parallel to HP. That means what you have here is the true length of the diagonal. Okay, the true length of the diagonal AD. When you pull it like this, still it is made parallel to HP only. That is, the entire thing is made parallel to HP only. As a result, this top view and this top view will remain same. Okay, when you pull it with A as the pivot point, when you pull it like this, such that corner A is in VP, this entire AD will be parallel to HP only. When we parallel to HP only, then the top view will be in the true length only. That means this top view and this top view is the true length of the diagonal AD. This length and this length remains same. That means at this stage you can say corner is in VP, with surface or diagonal AD inclined at 30 degrees to VP. Okay, corner in VP, diagonal AD inclined at 30 degrees to VP. Then when you look from here, okay, this top view and this top view will remain same. Okay, you take the projectors up, get the front view. That is, when a corner is in VP with surface as diagonal inclined at 30 degrees to VP, when you are looking from here, you get this type of front view. As you see here in this position, all the sides are in true length. Now once it is tilted, all have lost true length. All the edges have lost true length. Okay, that means this problem we have completed up to 2 stages. Now what do you see here? A dash D dash is inclined at 45 degrees to HP. Okay, see here, A dash D dash is inclined at 45 degrees to HP means you understand that A dash D dash, here AD, diagonal AD is inclined at 30 degrees to VP. Okay, but since it is inclined to VP, in the front view, this A dash D dash is not in true length. Okay, A dash D dash is not in true length. That is why the problem what I have done is, what I have done is A dash D dash is front view of the diagonal contains the corner in VP. This is, please mind that this is not true length since it is inclined at 30 degrees to VP. Okay, 30 degrees to VP, this is not in true length. That is why what I have done here is, as per the problem given, front view of the diagonal contains the corner in VP is A dash D dash. Front view, it is not true length. Okay, front view is inclined at 45 degrees to HP. Okay, 45 degrees to HP. In this problem, you have to, when you look from the top, how it appears in the top view has to be drawn. Okay, this has to be drawn. You see here, in this position, what you should know is, okay, the surface is inclined, surface or diagonal inclined at 30 degrees to VP. That means pivoting at A, that is, A is in touching VP. As long as inclination to VP is constant, even if you rotate this lamina in any possible way, okay, the front view does not change. That is why this second stage front view is same as third stage front view, because inclination to VP remains same. I have rotated in such a way that keeping inclination to VP constant at 30 degree, front view of the diagonal contains the corner is inclined at 45 degrees to HP. Okay, that's why A dash D dash is inclined at 45 degrees to HP. You see the thing. Now you see here, what I've done is, I could have done for the same thing, I could have done the top view. Okay, I could have done the, when you're looking from that top direction, how it is seen in the top view has to be written. But they are given one thing, a hexagonal lamina of size 30 has a corner in VP, resting on HP means, you see that now all corners are above XY line, correct? No? All corners are above XY line. All are above, that is at some distance above HP. This is some distance above HP. All are above HP. But resting on HP means you don't write the front view this way. You see that the nearest corner touches XY line such that A dash D dash is inclined at 45 degrees to HP only. Okay. This is a very good problem from the examination point of view. Considered as a very good problem and a good problem. That is, only people who have a clear understanding of the subject can do such problems. Okay, now see here, corner in VP, diagonal inclined at 30 degrees to VP. Okay, resting on HP means, see that the nearest corner touches XY line. Okay, that's what I run. Okay, this is nearest corner is touching XY line. That means the nearest corner, it is resting on the nearest corner B on HP, such that the front view of the diagonal contains the corner in VP is inclined at 45 degrees to HP. Okay, 45 degrees to HP. Now you take the projectors and take the points and draw projections. Okay, this is 39 from video textbook. Okay, up till here you have to be, that is, this type of problem are difficult ones. But if you understand, you see the video, okay, and you can repeat seeing also and see that every aspect is understood. Okay. Now you see here, this is a circular lamina of diameter 30, has a point of its circumference on VP. Had it been on HP, I would have started from top view. But they say it is circumference on VP and rotated about this point till its front view appears as an ellipse with minor axis 15 mm. Determine the inclination of lamina with VP. Draw projections when a point in VP is also touching HP and the lamina is perpendicular to RVP and all that. These things can be managed. But you see here, the problem is a circular lamina of diameter 30 has a point of its circumference on VP. When a point of its circumference on VP, you have to start from the front view. Had it been on HP, I would have started from top view. That is why it is brought under the classification of front view starting. Okay, now you see here, you start from the front view. A, B, C, D, E, F, G, H, all dashes because front view, diameter 30. And in the top, take the projectors. When you're looking from the top, A is this, H can be seen, B cannot be seen, H bracket B, G can be seen, C cannot be seen, G bracket C, F can be seen, D cannot be F bracket D, and E. Okay, they say this lamina is inclined to VP at certain angle such that this circle will look like an ellipse with major axis 30 and minor axis 15. They have said clearly given it looks like an ellipse. Okay, what you do, no, since the front view is already given, you make this 15. Okay, anyway, this diameter cannot change. Let it be 30. You make this 30, 15, get the center line and all that. Take the, this is, using this, this is 15 minor axis. This is 30 major axis. Using that ellipse command in solid edge, take the center first, then take the center point, then take it to this, okay, click it here and take it here, take it to G dash or C dash, click it here, you get directly the ellipse. Okay, then what you do now, once you do this, take the projectors down. And as you know here, the first stage top view will be same as second stage top view because A dash E dash is a diameter parallel to HP, and even after tilting it will be parallel to HP only. The true length can be seen in the top view. That is why this top view and this top view are same. You move and copy here and rotate. Okay, rotate here. Okay, then measure this inclination here. Okay, measure this inclination. This is 60. For this inclination, okay, you can take the points here and it will meet with the same points. Okay, in that way, for 60-degree inclination, this circular lamina will look like an ellipse with major axis 30, minor axis 15. This is the front view starting problem, a typical problem given. Then you see what exactly I've done. This inclination to VP is constant. Okay, whatever is that. But that means this ellipse is constant. Okay, I not change this ellipse because inclination to VP is constant and it is front view is appearing as an ellipse 30 by 15. This I cannot change. But I have made point A is on VP. You see here, if you carefully observe, I have made A dash only on XY line. That means point A which is in VP is also on HP. Okay, please understand. Point A which is on VP is also on HP. Okay, since the inclination to VP is constant and whatever you do, okay, the front view cannot change. Take the same front view, move and copy, paste and rotate in such a way that since the point in VP is also in HP, you see that A dash is on XY line. Take the projectors down and draw this top view. Okay, where's the final top view? Okay, once you do this, when you're looking from the top, how it appears in the top view has to be drawn. This is how you have to complete a very good problem under circular lamina front view starting. Okay. Now it's here problem 23, one extra problem also I done. Here same thing you start. A circular lamina of diameter 30, okay, has a point of its rim or circumference on VP. Surface is inclined at 30 degrees to VP. Okay, surface is inclined at 30 degrees or diameter inclined at 30 degrees. The diameter is AE, okay, that is in true length, the same true length, okay, 30 degrees to VP. Get the front view. Then what you do is A dash E dash is what? Is not in true length because 30 degrees AE, here it is in true length, 30 degree. In the front view, it appears reduced. Then the question is, the front view of the diagonal containing the point in VP, that is A dash E dash, is inclined at 45 degrees to HP. Okay. For this, when you are looking from the top, how it appears has to be drawn. Okay. Take the projectors down and draw the projections. In that way, a good problem on circular lamina, an extra problem also has been completed. Okay. Okay. Now, what I suggest is, see here, this problem you should know clearly. As soon as you look at the problem, you should know. I have started from front view. I got all the points here. Okay. And you know very well, it is A is in VP and surface or diameter inclined at 30 degrees to VP. Okay, it's a point in VP, not point in HP. Point in VP, that is why I started from the front view. 30 degrees to VP, you got the front view. And the front view of the diameter containing the point in VP, that is A dash E dash, is inclined at 45 degrees to HP. Okay, for this, when you're looking from the that is top, how it appears has to be drawn. This is how it is drawn. Now we come to the end of session 11 on projection of plane surfaces front view starting. Thank you very much for watching. Thanks again. Thank you.